Hi, folks. Hope you can hear me well. Can you please ping on the chat if you hear me well? Okay, great. Thank you. Yeah, and thanks for joining in. I'm Prabhat Sirivadana from WSO2. This is our fifth IAM for Developers Meetup. So we covered so far about JWT, then OAuth, OpenID Connect, and also security microservices with Istio Service Mesh. Next meetup, once again, we are going to talk about microservices, security service interactions that happen over gRPC, Kafka, and HTTP. So probably it will happen in 2 weeks' time, and if you find time, please join that as well. Yeah, and before we start, like a couple of housekeeping items. You all are muted now, but in case if you have any questions, please feel free to unmute yourself and speak up, or else you can use the Zoom chat to ask any questions. Yeah, so if you hear about WSO2 for the first time, it's a company which produces a set of open source products. We have an identity server, and that's the product I've been leading for last 13 years. And we have an API manager and also an enterprise integrator, all released under Apache 2.0, the most business-friendly open source license. In this session today, we are going to talk about single logout dilemma. So here we'll start talk about expectations from single logout, as a developer or also as an end user. So we'll briefly touch that, and then we'll dig into details of single logout protocols that's been implemented using SAML 2.0 and then OpenID Connect. Here, I've listed set of expectations that that we could gather by listening to our customers and also listening to other communities. I think Alan is in the call. So Alan got involved in this discussion that happened at IIW a few years back. So in that discussion, it was discussed like user experience, like how you want to expectations from the user when doing single logout. Alan, you want to comment on that? If you remember that event?
Yeah, I remember the event. I don't think we came up with an answer though.
Yeah, yeah. I remember even after this one, it was discussed a couple of times as well in some IIWs. Yeah, you can find the meeting notes here. Yeah. So IIW is an event that happens at the Computer History Museum twice a year. It's a very nice event. You can get a lot of like insights into ID protocols and also like how the blockchain is being used in the ID domain. So that's the like hot topic for last few IIWs. Yeah. So let's go through some of the points here. So one key expectation is when you log out from an application, you expect all the sessions that you maintain under that browser session for all the applications connected to an IDP to be logged out, right? And also you expect your login session at the identity provider to be terminated. So that's one key. That's the like core expectation. And you can extend that to another level. Like, so there can be a case where your application connects to an IDP. So there can be a set of service providers or applications connect to one IDP. And that IDP can connect to a set of outbound federated IDPs, right? So there's a one IDP where all your applications trust, and then that IDP can connect to multiple other IDPs, right? So the user's account would come from these external IDPs. In that case, you expect all your sessions to be terminated from the corresponding applications under that particular browser session, and also the first IDP session, and also you expect the second IDP session to be terminated as well. Then the third one, the single logout should happen irrespective of the federation protocol. So these service providers could support SAML, OpenID Connect, WS Federation, CAS, or any other federation protocol. But you expect if you log out from one application, you should get logged out from all the other applications connected to that particular IDP, irrespective of the federation protocol that you follow. Then the fourth one we see is logout from one application and logout from the same application used across multiple devices. For example, you may log out from your Gmail account from your browser. Then you expect you being logged out from all the other like applications running in other devices, like the Gmail app running on your iPhone, iPad, likewise. But that's a very rare expectation. Rather than single logout, it's like a session termination, right? So if you go to Gmail, so Gmail has an option like you can terminate the session, either the current session or all the sessions across all the devices. Then again, like how the single logout experience should be, like when I close a browser or a tab, should I get logged out automatically, right? Or else, even you initiate a logout from the application, you shouldn't rather log out user from all the other connected applications without getting users' consent, right? So the discussions happening at the moment, even now those things happening. So those are the discussions happen at IIW2. But in this session, we are not going to discuss those in detail, but mostly going to focus on the technicalities associated with these federation protocols, SAML 2.0 and OpenID Connect. And also, I expect you have some understanding about how SAML and OpenID Connect works. In fact, as we discussed before, we did a couple of sessions on OO2 and OpenID Connect. So that covers a lot of details on like underneath how those protocols work. Let's get started with SAML 2.0 first, and then next we'll move to OpenID Connect. Here in SAML 2.0, so there are, if you look at the SAML specification, there are 4 main components in that. One component is assertion, right? So there are multiple assertions. It can be an authentication assertion, authorization assertion, or else an attribute assertion. So it's basically a statement about you in a given format. Then you have a protocol, a request response protocol. So it defines like how you can combine this assertion together, right? In the request and in the response, and the schema for request and the response. Then you have bindings, right? So a SAML binding defines how you can transport a set of or a SAML request from one place to another place, or SAML response from one place to another place. For example, if you try to embed a SAML request into a SOAP message and transport it from one place to another place, so that we call SAML SOAP binding. Or else you can transport a SAML request in an HTTP redirect, so that you call SAML HTTP redirect binding. Also, you can transport a SAML request as an HTTP post, so that we call HTTP post binding. So likewise, in binding, it says how you, specifically it says how you can transport a SAML request or SAML response between two parties with a given communication channel. Then finally, we have SAML profiles. A profile defines how you can use assertions, then this protocol, and also the binding to address a concrete use case, right? So it combines all these 3 components. For example, SAML single sign-on is a profile, which tells you how to use these assertions to address this single sign-on use case. In the same way, single logout is also a SAML profile. So that's what I want to highlight. So if you look at the SAML spec, if you want to get into more details, you need to look at the SAML profile specification. It defines set of SAML profiles, including single sign-on, single logout, like that. So let's have a look at how this works. So we are going to internals, and if you have any questions, please feel free to ask. So here we assume first you have already logged into the application 1 using SAML, right? So both application 1 and application 2 trust the identity provider. So identity provider is the issuer of the SAML token. Now application 1 has a SAML token. To initiate a logout, the user goes to the browser and click on logout link, and that will do a get to the application. Then application will create a logout request. So logout request is another XML payload. Then you redirect the user using HTTP redirect to the IDP's logout endpoint, passing that logout request, right? So in this logout request, there's a special parameter called session index, right? So if you have enabled single logout for SAML, then in the login flow, when you get the login response, SAML login response, The IDP will also include an attribute called session index, right? So you need to send the same session index value when you initiate logout from the application one, right? Then the service provider, the IDP knows how to correlate the login request, login response, and also find the corresponding session of this particular user, right? In addition to the session index, you also need to send an attribute where the IDP can identify the subject or the principal, right? Then you know the user, you know the user session, so then identity provider can terminate that session, right? So now you get the logout request from the application one to the IDP, and also this request must be signed, or the application one should authenticate to the IDP. So the ideal way is you just sign the logout request from application one to the IDP. Then IDP will validate that logout request, and then so everything we discussed so far is front channel, right? In fact, SAML specification has two ways of doing this. One is front channel, or we call it asynchronous. The other one is back channel, which is synchronous. And also you can combine these things together. So in this particular diagram, we have combined both synchronous and asynchronous flows together, and this is the most common flow we see. Now in the front channel flow, IDP got the logout request. After that, IDP will find out what are the other corresponding service provider which user has logged in under the same browser session, right? IDP can easily correlate that, because when in this logout request, it will also bring all the IDP cookies. So then IDP can find out the user session that it maintains at the IDP site. Then from that, it can find out all the other service providers user has logged into. Then after that, if the IDP and the corresponding service providers, they follow the back channel logout mechanism, then IDP will create a logout request, another SAML request, which is signed by the IDP, and will do a post. And then application one, it's responsibility to terminate its own session and send the logout response back to the IDP. And the IDP will carry out this thing, this request response thing, for all the connected service providers user has logged in under the current session. Here in the logout request, either like the IDP can send the session index, but it's not a must. But for the first initiator, it is a must to send the session index. But in this case, you don't need to necessarily send the session index. You can just send the principal name. If you send the session index, then application one can specifically terminate that session of the user. But if you don't send the session index, then the application two has to look at the principal name and terminate all the sessions associated with that particular principal, right? Yeah, so once that is done, then the IDP will create a logout response and do a 302 to the application's logout URL. Then again, you are back on the application one, right? Now there's a question here. So in back channel flow, the IDP asks the application one to terminate your back channel session, right? At the same time, uses a front channel session too, right? So if you go to this diagram, so the identity provider asks the app2 to terminate its back channel session, but it doesn't so app2 doesn't know how to communicate this to front channel, right? To browser. It doesn't have a way to propagate that decision to the front channel. So to fix that problem, what you can do is the application running on the browser can query periodically given endpoint in app2 to see whether the back channel session is valid or not. So you can implement your own endpoint. Let's say you have an endpoint called check session. Then the browser will, any script running in the browser will poll that endpoint, and when the back channel got expired, the back channel session got invalidated, this will return back, say the session is now invalidated. Then the browser can invalidate the front channel session as well. Yeah, I think there's a question. What are use expectations if logged into the
That's user expectations.
Yeah.
User expectations.
What are the user expectations if logged into apps using different IDPs? I don't think users are aware of which IDP is used for each login. Yes, so ideally, you will log out from the IDP that your app connects to, right? So you have application 1, it will trust IDP, this IDP. If there's another IDP 2, right, for app 2, then you won't be log out from app 2, even if you log out from app 1, because they are in 2 trust domains. But there can be a case, if you go to this one, I show a demo of this too. Here we have 2 IDPs, right? App 1 trust IDP 1, app 2 trust IDP 2, right? But now we have built a trust relationship between IDP 1 and IDP 2. In that case, if user logs out from app 1, it will propagate that decision to IDP 1. Since IDP 1 trusts IDP 2, IDP 1 will also propagate that decision to IDP 2. Then IDP 2 will initiate logout request for all the connected applications that user has logged in under the current browser session. Right? So this is a typical expectation. If there are disconnected setup, right? If there's a disconnected setup, you don't have direct trust relationship, then probably you need to use a different protocol to communicate this logout decision. For example, like under OpenID Connect Foundation, there's something called risk profile, right? So with that, you can communicate these logout decisions, then they can make their own decision at that point. Okay? So let me go through a example. I'll show you how this works in reality. Once again, I'm using Identity Server just because that's the product I'm mostly familiar with. You can use any other IDP out there. All the external communications are standard communications. There's no proprietary APIs I'm talking about. Only thing that you would find different here is I'm using Identity Server specific UI and way to configure that protocols or the service providers, right? So here first I need to log into the Identity Server. Yeah, I need to log in to Identity Server. This is all open source. If you go to wso.com, you can download this one and try out. So here I have defined a SAML to IDP, SAML to service provider. If you go to inbound authentication configuration, SAML, edit. Right. Here I have enabled single logout, right? So that means when I enable single logout, every time a user logs into this corresponding service provider through the IDP, then IDP will include that session index to SAML response, right? Authentication response. Okay. That's mostly it. Let's see how this works. So this is the service provider URL. If I go here, let me see the service provider is running. Yeah, probably I haven't started that. Let me start the. So it's a web app running on Tomcat. Yeah, it got started. Yeah, so now let me start the SAML tracer too, so we can see exactly what's happening. I'll take it to a different terminal. Now, when I click login, so it took me to the login page of the Identity Server. And if you look at the SAML tracer now, you will see a SAML request. Right? So this is a SAML request. It is initiated from this dispatch application. Right? So this request is signed. Right? And then let's log in here. Okay, now I'm logged in. Now, once again, if you look at the SAML tracer, this is SAML request and this is SAML response. This is SAML response. Now, if you look at this one, you can see an authentication statement, right, which has a session index. So we only need this session index in the authentication response if we are going to use single logout. Let's clear this one. And now we are logged in. Now let's see like how to log out. And if you are using this particular sample lab, so this is also in our Git, you can also see the SAML request from here, SAML response from here. Yeah, now let's see what will happen when I log out. Okay. So I logged out. Now if you go to the SAML tracer again, so this is the logout request. So yeah, the SAML tab. Here you can see I am sending this session index. So this is the same session index I got in the SAML response in the previous flow. Then and this has to be signed to. So this is signed by the dispatch application, and then you will get back the SAML response from the IDP. It also goes to the browser, right, with this success status code. Okay, so now we'll see how to extend this to the federation use case. So now I have this particular IDP. You go to login. The identity server is running on port 9443, right? So let's call this IDP1, right? Then I'm going to introduce another IDP, same identity server, different identity server instance, which is running on port 9445, and let's call that IDP2, right? So now when I try to log into this dispatch app, my expectation is this app will go to IDP1, then will automatically redirect it to IDP2. And user from IDP2 will log in, and then you send a response back to IDP1. Then IDP1 will send a response to the dispatch application, right? Still, the dispatcher only trusts the IDP1, but the user comes from IDP2, right? So this is how you do that in identity server. You need to introduce an identity provider. I have already done. This is the IDP2 or 9445 IDP. You go here, and under federated authenticators, I have configured a SAML connector. So then IDP1 connects to IDP2 over SAML, and also I have enabled single logout, right? So I have enabled single logout profile. Then I need to change the login options for the SAML application. So here, by default, it uses the username password based login. You go to local and outbound authentication configuration. Now I can pick federated authentication option. Then it will list out all the IDPs and systems. Since I only have this IDP2 or 9445 IDP, it's listed here. That's it. Now I need to go to 9445 IDP or our IDP2. And then add IDP1 as a trusted service provider there. So this is 9443 or the IDP1. And under inbound authentication configuration SAML, so we have configured IDP1 as a service provider. So it can send a login request as well as a logout request to this particular IDP. And we have enabled single logout too. That's it. Now, if you go back here to this application, okay, then when I click login, you don't need this. Okay, I think this is the OpenID Connect app. This is the application. Let me quickly get its URL. Yeah, this is the URL. So now when I click login, earlier it went to 9443, now it should go to 9445, right? Yeah. So now you can see I'm on 9445. So that is the federated IDP, outbound federated IDP or the IDP2, right? So I didn't do any changes at the service provider side. Service provider still trusts or knows about IDP1. It doesn't have any knowledge about IDP2. So let me log in as a user in IDP2. Now I'm logged in here again. Now, if you look at the SAML tracer, I think I didn't, I have posted. So let me try it out again. Log out. Now I'll try login again. Yeah. Now if you look at the SAML tracer, you will see two SAML requests and two SAML responses, login request and login response. So this is the login request generated from the dispatch app to IDP1, and this is the login request generated from IDP1 to IDP2. This is a login response coming from IDP2 to IDP1, and this is a login response coming from IDP1 to the application. Now let's see how the logout works. So when I log out from here, it will also log me out from the second IDP. If you look at the logout flow, so once again, you will see two logout requests and two logout responses. This is a logout request generated from the application, dispatch application to the IDP1. Then this is from IDP1 to IDP2, and this is login response from IDP1 to IDP2, and sorry, logout response from IDP2 to IDP1, and this is the logout response from IDP1 to the dispatch application. In case you had multiple service providers connected to IDP1 or IDP2, which support the SAML 2.0 logout protocol, then you will also get logout from all these applications too. Okay, there's a question. Is the user Peter provision in IDP2 and IDP1? Does the app itself have a user store? Yeah, so in this particular case, user Peter is only in IDP2. IDP2 doesn't know anything about that. Sorry, IDP1 doesn't know anything about user Peter. IDP1 only acting as a bridge, right? So app itself, yeah. So in this case, app doesn't need to have a user store, right? But there can be a case app needs to store the user attributes, right? So in that case, what you can do is, rather than app itself taking that burden, when you define an IDP in when you define the federated IDP in IDP1, if you look at here, this is a federated IDP, right? You have an option to just-in-time provision the user, right? So that means when you go to IDP2 and come back, identity server will automatically provision that user to the IDP1's user store, right? So once again, this is out of the scope of SAML. This is how like different IDPs implement that, right? So I can show you if you want. So here I can say always provision user to the primary user store. You can have multiple user stores too if you want, and then provision silently. That means you won't like tell the user that you have been provisioned. But in case like if you are worrying about privacy, if you think you need to get the user's consent before adding the user's attributes you get from IDP2 to IDP1, then you can ask user's consent before you provision. You add this option here. Then if you go to users here, you don't see a user called Peter, right? Now let's try to log in to this one. Now I'm on IDP2. If I log in as Peter, okay, now ideally I should see a user called Peter here. Yeah, so Peter been added here. In this request, we don't get any attributes, so we don't see any attributes. But if you request any attributes, you can just-in-time provision the user attributes to the IDP1 as well. So in that case, all your service providers only trust IDP1. And then if they want to retrieve users attributes, then you can just talk to the IDP1's API and fetch the attributes. This is specific to IDP implementation. If you look at other IDPs, they might have implemented that in different ways. Yeah, so let's go back to the slides. Yeah. Okay. So the other option is you can make all the flows front channel, right? So previous case we had this flow front channel. this flow front channel, but this was back channel, right? So now you can make everything front channel. So the first communication is same as we discussed before, but once you get the logout request from the first application, now IDP won't do direct calls to the connected service providers. It will look at all the service providers in that particular session the user has logged in, and will do HTTP request, HTTP 302s to the logout endpoint of each application. You basically redirect the user to app 1, then app 1 will once again redirect back the logout response to the IDP, and it will repeat this to all the service providers the user has a valid session under that particular browser session, right? But just by looking at this, you can see this is very fragile, right? So anything can go wrong at any point, because if you are like multiple service providers, you need to follow this redirection flow for each and every IDP. So this is not that much usable and a very fragile approach. If you look at how the same thing being done in OpenID Connect, it has improved a lot, like how this communication happens, and we'll talk about that later. So once all the sessions been terminated at each and every service provider, then again the IDP will do another 302 to the logout endpoint of the application 1 with the logout response. And then again, all these communications can happen over any of this binding. It can be HTTP redirect binding, HTTP post binding, or artifact binding. Here in this particular diagram, I am using redirect binding, right? So if you change the binding, you just need to follow the rules defining that particular binding. Then in this case, we discuss how the end-to-end communication happens over back channel, right? So here there's no communication happen through the browser. So when a user logs out from the application 1 will send a direct call to the IDP 1 sending a logout request. Then the identity provider will also use the back channel communication to inform the logout request to other connected IDPs. And once that is done, it will send a logout response to the application 1, right? So once again, in this approach, you need to have a session checker running in the browser of each application to correlate the front channel with the back channel. So when you logged out from a back channel, then that will be detected by the any script running in the front channel, which will like keep polling a known endpoint in the application. Right. The most common flow we see is the first one. You combine the front channel with back channel. Okay. Now we'll move to the next section, OpenID Connect. So I won't go into like OpenID Connect and O2O details, but I'll mostly focus on the logout session. So if you are not that familiar with OpenID Connect or O2O, so we have 2 sessions. Like all the recordings are in our YouTube channel. If you go there, you can find how like the internals of O2O and also the OpenID Connect internals. So here, this is the authorization code flow in OpenID Connect. And now, if the OpenID Connect reliant part of the application won't support single logout, OpenID Connect has 3 ways of doing that. So one way is defined in the session management specification, and there's another specification called front channel logout, and there's another specification called back channel logout. So we'll go through all 3 of them. First, we'll discuss how the session management specification works. If your application won't support session management, and if your IDP supports session management, when you initiate the normal OpenID Connect authorization code flow, in addition to the authorization code, IDP will also send you something called session state, right? So we'll discuss what session state is later, what session state means later, and how we are using this in the logout flow. Also, when you send the session state, IDP will also write a value to a cookie called OPBS under the IDP's domain name, right? So under the IDP domain name, you create a cookie called OPBS. Then after that, it's a normal OpenID Connect flow. You got the authorization code here, then you will exchange that to a token, an ID token. Then you send the response back to the user. So user is now logged into the application. Then if you are supporting session management specification, the application has to load 2 iframes. So one iframe you load from the Reliant party, and the other iframe you load from the OpenID Connect provider, right? So now at the end of this login flow, you have a session state, and there's an OPBS cookie written under the IDP domain name, and then you have a Reliant party iframe, and also you have an OpenID provider iframe. So we'll talk about this, like how we are going to use these 4 components to establish single logout in the next slide. Okay. So now you are logged into the application. Now once you are logged into the application, you have these 2 iframes. Those 2 iframes will start communicating with each other, right, using the post message API. Now after some time, maybe let's say every 5 seconds or 10 seconds, the RP iframe will send a message to the OP iframe. This message will include the client ID and session state. So the client ID is the client ID of the application. So RP iframe knows about it. Session state is the session state we got from the IDP with the authorization code, right? So this is a complete algorithm, right? So you derive the message by concatenating client ID and session state. Then also you find the target origin. So target origin points to the IDP domain. Then you find the location of the OPI frame. Then you send the post message to the OPI frame, which include the message and the target origin, right? Then this request will go to the OPI frame, receive message. It will extract out the client ID from the request, from the message it gets from the RPI frame. And also it will extract out the session state. So now you know the session state, which is sent from the RPI frame and the client ID. And session state has another thing called, within the session state called salt. You extract that out too. After that, OPI frame will also read the value of the OPBS cookie. So the OPI frame can read this value of this cookie because OPI frame is loaded from the OpenID provider domain, and also this OPBS cookie is written under the OpenID provider domain, right? So this iframe can read it, but RPI frame cannot read that value. Now, after that, you derive the session state value, right? So this is how, at first place, like OpenID provider derive the session state value too, right? You concatenate client ID with origin, this IDP endpoint, and the value of the OPBS cookie and the salt, and you derive the SHA-256 of that, and then you concatenate that with the salt value. So this is how you derive the session state, right, in first place. So basically, in the initial request, the IDP derives the session state and send that to the RP. So RP has the original session state, and this again calculate the session state with the latest value of the OPBS cookie. Now, if the calculated session state matches with the original session state sent to the OPI frame from the RPI frame, then you will send a status back saying status has not changed. Basically, you send a message called unchanged. So if it's unchanged, you don't need to do anything, right? So here in this communication, there's no traffic happens over the wire. It's only between iframes, right? So if you look at your developer tools in the browser, you won't see any like wire communications. Only happens between iframes. Now, at this point, if someone logs out from OpenID provider, what's the best way to communicate that decision to this particular application? The best way is the OpenID provider has access to this OPBS cookie, right? So what it does is, if user logs out, the OpenID provider will change the value of the OPBS cookie, right? So now when this RPI frame keep on like polling the OPI frame, here if the OPBS value changes, it will also change the calculated value of the session state, right? So now the OPI frame will detect the new value of session state is different from what it originally got from RP-iframe. So that means OP-iframe now knows something has changed at the OpenID provider end, and it will send a state saying changed, right? So if you got a changed status at the RP-iframe, then it has to send a message. Well, I think we have a sequence diagram for that. It has to send a message to the identity provider endpoint, setting prompt as none, and also you need to send the ID token hint. So ID token hint is the original ID token you got in the login response, right? So when you send authorization request to the identity provider or the OpenID Connect provider with prompt none, OpenID provider should not prompt the user to authenticate, right? Even if there's no valid session, you shouldn't prompt user to authenticate. If user doesn't have valid session, then you need to return an error. So now if user doesn't have valid session, IDP won't return an ID token. If user has a valid session, then it will return back a new ID token with a new session state value, right? Now RP-iframe will check whether you get an ID token or not. If it doesn't get an ID token, then RP-iframe will initiate a logout request, right? Also, you may get ID token with a different principal. Even if that is the case, you need to initiate a logout request, right? So it can be a case that you log into a different service provider application with a different value, or something has changed. Some of your values been changed. Then the ID token, the values in the ID token could change too. Even in that case, the RP can decide that we should initiate logout, right? So when you initiate logout, it happens in this way, right? This is RP initiate logout. So you detect, the RP-iframe detects the state change, and then it will generate a logout request, and it will send this logout request to the IDP. This happens through the browser. It's an HTTP redirect. Then the browser, sorry, it goes from the browser to the IDP. Then IDP will clear that session and will redirect back to the application 1. So now you are on application 1, but you are not logged in anymore, right? And in this logout request, you also need to send the ID token hint, which is the original ID token you got, and the post logout redirect URL. So that's this particular URL. You get redirected to the post logout redirect URL, and that has to be pre-registered with IDP2, and then a state value. So whatever the state value you pass here, IDP should return the same, right? So this is how the back channel logout end-to-end flow works. Yes, okay. So now there's a question: does the RPOP iframe session management scenario apply to SPS and regular web apps as well? Yeah, so this anyway applies to regular web apps, and this is the best approach for single page apps too, right? Because there's no direct communication happens between the service provider and the IDP, right? So basically your SPA needs to load these two iframes, and the iframe itself can detect any state changes. And if there's any state change detected, then application has to clear all the variables, the values they maintain in local storage or session storage, and initiate logout request, right? And so we'll discuss front channel logout later. You can use that too, but this approach is much easier to implement in an SPA use case. Okay. So let's see how this works. So I'll go back to the identity server. Here I have registered an OpenID Connect app. So if you go to inbound authentication protocols, OpenID Connect, here we support session management specification, and the other two specifications we talked about, front channel and back channel. At the latest IS release, we only support back channel, but we have implemented front channel too, but it's still going on. Probably by the end of this year release, we'll add that too. Okay. So I have enabled all the grant types. You don't need to have all these grant types, just pick whatever the things you need. And this has an option, yeah. So if you want to support back channel logout, you need to check this one. Otherwise, session management spec will be effective. Okay. Now, this is the URL for this particular application. Now let's enable developer tools too. So when I click login, it should take me to the identity server. So this is IDP1. I can log in with the user there. So I'm now logged into this particular service provider, right? Now those two iframes should be loaded, right? So those two iframes should be loaded and they should start communicating with each other. So let me go to the network tab, yeah, and clear this one. Okay. So now also we should see that cookie, right? This OPBS cookie should be there, but it has to be under not this domain, right? So if you look at the applications tab here, you won't see the OPBS cookie, right? You won't see the OPBS cookie. There's no OPBS cookie. But if you look at the 9443 domain, right? That is the IDP domain, you see this cookie, right? So let's see like what will happen if I change the value, right? Because the OPI frame keeps track of this value. So now if I change this value, let's see what will happen. It should send, let's go to network tab. Yeah, right. So it should send a prompt none request to the IDP. If you look at this one, it's a prompt none request. So if you look at this, here you can see prompt equals none, right? But still IDP will return your valid ID token because user has a valid session in the IDP, right? So that's why you would see still the user is logged into the application, right? So let's try to remove the IDP session. We can do that through the SAML app. Let me update this app just to use the first IDP. Now if I log into this one, okay. Now you don't have valid IDP session, right? Now if I change this value, still this will send a prompt none request and you won't get an ID token back. Then this app will initiate the logout flow. Right, so let's go back to the applications here and change this value. Yeah, now you can see you got automatically logged out, right? Because if you look at the request, you saw like this is sending a prompt none request. You didn't get an ID token, right? Then that means user has logged out. So this initiated logout from the application side, right? If you go to slides, so this is the flow we just saw. Yeah. So it detected there's a session change, and then it initiated this logout request, right? First, it checked with the prompt none request, right? This one, prompt none, right? You didn't get an ID token, then it initiated the logout flow. Okay, so this is how the session management logout works. Then let's see how front channel logout works. So this is a bit similar to what the way front channel works in SAML 2, but very much improved. Here also, you initiate a logout request from the application. So you send a logout request to application 1, then application 1 will redirect you to the IDP, right? The logout request. Now, IDP will find out all the corresponding service provider that user has logged in under the current browser session. And if in case of SAML, it will initiate a HTTP redirect for each and every service provider, right? In this case, it won't do that. It will simply find out what are those service providers and what are the logout URLs of all these service providers. And it will create an iframe for each and every service provider, each and every application, and create an HTML page with that. And we'll send that HTML page or render that HTML page on the user's browser. Now you have a set of iframes. Now each iframe will automatically execute the call to the logout endpoint, and everything will happen parallel. So after all the iframes execute, either you can do get to the application once logout URL, or else you can do a get to the IDP endpoint. Then IDP endpoint will do a 302 to the logout endpoint of the application. Right. So this is how the front channel logout works. And if you want to use this in a single page app, you can still do that. Only thing is you need to have an endpoint to get this logout request. Right. So you get this logout request from an iframe, then it will send back an HTML page, right, which will clear any of the values that you keep in session storage or local storage in the browser, and logout user from there. Right? But it's always ideal. What we have seen is people use the session management for SPA logout. Any questions, or are we all good? Okay. So the next one is back channel logout. Once again, it's initiated from the application the same way we discussed in all three approaches, right? It comes here. Now, instead of doing a redirect, IDP will directly talk to an endpoint of application 2. It'll keep doing that for all the connected service providers that users logged in under the current browser session. So here you are sending a token called logout token. So that is a signed JWT, right? Which will include the principal and also something called session ID or SID. So looking at the user and session ID, application can find out who the user is and find the session and terminate it. If you don't include the session ID, just a subject, then once again, just like in SAML single logout flow, you will terminate all the sessions associated with that particular user. And once again, we need to have a session checker running in the browser, which will keep polling a backend endpoint, see whether the back channel has expired. If so, you should terminate the front channel as well. One thing I forgot here. So even in this logout request, you will send issuer and SID. So issuer is the IDP, and the value represent the IDP. Then the SID is a session ID, right? And this session ID should be in the JWT2. Like if you support the front channel logout or the back channel logout, then when the application, IDP at first place issues a JWT in the login flow, it also should include the parameter called SID, session index. And you need to pass the same session index in the logout request. And if you don't send the session index, session identifier, if you don't send that SID value, then app 1 should terminate all the sessions associated with that particular user. Right? So here is the same thing. You send the same session ID that the IDP included in the original JWT. Okay, so this is how the back channel logout works. So this won't people don't use this for single page apps. And you can still use it, but that means you add more load to your backend, right? So backend has to, you need to have backend endpoint, and backend endpoint has to process this message, and then again from the front channel you need to poll the back channel. So that's why this is not suitable for SPS. Yes, I think that's what I plan to cover. If you have any questions, we can discuss those now.
Hi, Prabhav.
Yeah.
So there, with the cookie issues and all these iframes, is there some best practices for the cookie settings, the same site mode settings and that sort of thing?
Yeah. So basically, you need to follow the best practices you follow, when you embed when you embed iframes to any web app. And also, so if you look at the OpenID Connect specification, so it has defined set of not many, some security best practices, like how you want to check the origin of the request to see whether from the OP iframe you need to see whether the origin of the calling iframe is also the origin of the parent of the OP iframe. This is the this is session management spec. Yeah, if you look at the security considerations, you can see they have defined like how you want to do that, how you want to build that.
Okay, great.
Yeah, any other questions? Okay, then thank you very much, and so hope you will join our next meetup too, probably in 2 weeks' time. And stay safe, and thank you very much.